Hey guys, this is Mr. Sal. We're going to look at a lesson about solving and graphing multi-step inequalities. Thanks for watching. Alright you guys, let's go ahead and start this lesson off with a quick starter problem. So we got 8 of them. Just determine which of these are rational and which are not. I'll give you guys a couple minutes to do that. Alright, you should have that done by now. So let's go ahead and look at these ones and determine which of them are rational. So a rational number is a number that can be written as a proper or improper fraction, or also decimals that repeat or terminate. So number 1, this right here is an integer already, so we know right away that it is rational. Again, we could write it as an improper fraction with -4/1. So this one is rational. -0.34. This number is a decimal that terminates because it doesn't show any decimals after the 4 decimal values. So we know also that this one is rational as well. The square root of 7. 7 is not a perfect square, and we're taking the square root of something that's the non-perfect square, so this one would be irrational. 0. This is a whole number that's also an integer, which makes it automatically qualify as a rational number. Number 5. This one is a proper fraction, so this one is also rational. Number 6. This one is taking the square root. The negative is okay because it's outside of the square root, but 11 is a non-perfect square number, so this one is irrational. The square root of 81. If we took the square root of 81, we would get 9 because 81 is a perfect square. So the square root of it is a whole value, and therefore the square root of 81 is rational. The negative cube root of 27. Again, if we plug this into the calculator, we would get -3 because 27 is a perfect cube. That doesn't matter to us right now because we can plug that into the calculator, and when we do, we get that -3. -3 is an integer, which means it's automatically rational. So it looks like all but number 3 and 6 were rational. Alright, here's our objective. I can solve and graph multi-step inequalities. Take 30 seconds to write this one down. Alright, so in the last lesson, we solved and graphed 1- and 2-step inequalities. So there was, in order to solve those, we only did 1 step or 2 steps in order to solve them, but these ones may require many steps, which may include distribution, and it's just the same thing as solving equalities. But the difference now is that inequalities, just like in the last lesson, is if we ever divide or multiply both sides by a negative, then we have to flip the inequality. So for example, if I had -5x, and let's say that this one is less than or equal to 25, in order to solve this one as an equation, I would divide both sides by -5. Well, since I divided both sides by a negative, that's going to flip the inequality, and the rest of the math is the same. -5 divided by -5 is 1, so that would give me x, but now it's greater than or equal to 25 divided by -5, which would be -5. So we need to remember this rule when we're solving these inequalities, because otherwise we're going to solve them and graph them incorrectly, even though they would be very close. So the directions are to solve each inequality. We'll show all steps and then check your solution. Just remember, if you ever multiply or divide both sides by a negative, you're going to flip that inequality. So we're going to do 2 problems at a time. We'll give you guys 2 minutes for each, and then we'll go over both of them together. So your 2 minutes starts now. Do it with a neighbor. Talk to each other how to do these, and then check your work with what we do. It's okay if you get them wrong, again, because we're still learning this stuff. So just work hard, talk to each other, and then take the notes. Check your work with what we do, okay? Here you go, 2 minutes starting now. All right, let's go ahead and solve both of these. We'll start with number 1. First thing we'll do is start combining like terms on both sides, just like we would as if it were an equation. So I have 4m's plus 3m's, that would be 7m's. Then we still got this minus 8, and this is greater than or equal to negative 1. So none of that stuff changed, but let's go ahead and get rid of that minus 8 to isolate the m's by adding 8 to both sides of the inequality. So that leaves the 7m, the 8's 0 out, and this now is greater than or equal to negative 1 plus 8, which is 7. The last step is to divide both sides by 7, which gives us 1m, which we can just show as m, and that would be greater than or equal to 7 divided by 7 is 1. So in this problem, we did not divide both sides by negative, but we did divide both sides by positive, so we didn't have to change or flip the inequality. Alright, number 2, we're going to do the same thing. Start by combining like terms with the x's, and don't forget that's a 1x right there, so 1x and 5x's would be 6x's. Then we still got this negative 3, which is greater than this negative 3. So now, to solve this, I'm going to add 3 to both sides to isolate the x's. And it doesn't change the sign because we're only doing addition. So we're going to drop the 6x because the 3's 0 out. And negative 3 plus 3 would also be 0 right there. So I got 6x is greater than 0. Finally, to solve, we'll divide both sides by 6. Now that gives us 1x, which is what we want, which is greater than 0. So x is greater than 0. Now don't forget, if we were to put 0 into this inequality, it would be a false statement, because then it would be negative 3 is greater than negative 3, and negative 3 is not greater than negative 3. But if it had the equal sign underneath it, then we would be able to make the statement that it would be true. So anything greater than 0 for x would be correct, even including the decimal value. So if you put in 0.001 in for x, you would get a true statement. Alright, we'll give you guys a couple minutes to do 3 and 4 as well. Do it with your neighbor, talk about it, how you would do it. Again, be careful, because if you ever multiply or divide both sides by a negative, something has to happen on those ones, okay? Couple minutes, go. Alright, let's start with number 3. We'll go ahead and start solving this one. Alright, and on the left side of the inequality, we have some x's that we can combine here. Negative 4x's minus 6x's would give us negative 10x's. Now this is greater than or equal to 20 still, and now there's nothing to isolate the x's, they already are isolated. So we're going to divide both sides by negative 10 to make that a positive 1x. Negative 10 divided by negative 10 is 1. Now, since we divided both sides by this negative here, we are going to flip the inequality. So now it's not greater than or equal to, but it is less than or equal to. And 20 divided by negative 10 is negative 2. So that means that any value of x that is less than negative 2 would be, or would make that original inequality true. Additionally, if x were equal to negative 2, it would still make the original statement, negative 4x minus 6x is greater than or equal to 20. That would make that also a true statement. So this is our answer for number 3. All right, let's go over number 4 then. So on the right side of this inequality, I have the 3 and 6, which I can combine. And when I do that, I get a positive 9. So now I have 17 is less than or equal to negative 4p plus 9. But again, I want to isolate the p's, so I'm going to subtract 9 from both sides so that they will zero out. And 17 minus 9 would be 8, which would be less than or equal to negative 4p. But I don't want negative 4p's, even though they're isolated now. What I want is just 1p, so I will divide both sides by negative 4. Negative 4 divided by negative 4 is 1, so that's 1p. But once again, we see that we've divided both sides by negative. So what that means is we're going to flip the inequality. So instead of it being less than or equal to, now it's greater than or equal to. And we have 8 divided by negative 4, which is negative 2. So this is our answer. All right, here's number 5. Take a couple minutes with your neighbor and see if you can solve this inequality for n. Go. All right, hopefully that was enough time for you guys. If you're not finished, that's okay. Just finish up and then catch up to where we are and compare your notes and your work with what we have here. All right, so the first thing I'm going to have to do on this one is to distribute this negative 8 into this set of parentheses. But also, on this other set of parentheses, that's a negative 1, which I should distribute into this parentheses. So I end up with negative 8 times 5n, which would be negative 40 n's. And also negative 8 times, that's a negative 11, which would be positive 88. On the right side of the inequality, I've got negative 1 times 7n, which would be negative 7n. And also negative 1 times 9, which would be negative 9. So my new inequality is negative 40n plus 88 is less than or equal to negative 7n minus 9. So I've got to determine which side I want the n's on, and generally I like them to be positive, or that the coefficient of n is positive. So I don't like that negative 40n is what I'm saying, and I know I've got more negatives on the left than the right. So what I'm going to do is add 40n to both sides of this inequality, which will make the coefficient of n positive. So that still zeroes out, but negative 7n plus 40n would be a positive 33n. So the new inequality would be this 88, which we dropped, and that's less than or equal to 33n, and then we got this minus 9, which we will also drop. Now don't forget the objective right now for solving these inequalities. The first one is to simplify, whether it's through distribution or whatever, but right now we're looking to isolate the n's. So I don't want that minus 9 there, so I'm going to have to add 9 to both sides of the inequality. And when I do that, it appears that I would get 97. Yep, 97 is less than or equal to 33n. And negative 9 plus 9, that zeroes out. So the last thing I need to do here is divide both sides by 33. So that will give me 1n. Now I divided by a positive on this one. And 33 does not go into 97. So I'm just going to keep that as a fraction, as 97/33. Now that's okay. Some of you guys, if you put the negative, or the n rather, the n's on the left side of the inequality, you may have gotten this inequality. So that would be n. It's still going to be eating the n, and it's still equal to, but you should have still had the same fraction right there. So either one of these two would work as the answer for number 5. All right, here's number 6. Guys, take a couple minutes with your neighbor, do number 6, and solve for n. All right, hopefully you had enough time to do number 6. Let's go ahead and go through this one together. So once again, we see distribution on this one, so I'm going to distribute this negative 2 into the parentheses. So that'd be negative 2 times 12, which is negative 24. And also negative 2 times positive 5n, which would be negative 10 n's. So my new inequality is negative 21n plus 12, and this is less than negative 24 minus 10. Now again, I'm going to try to get positive n's, so I don't have to divide by negative, and I don't have to worry about that rule. So I got this negative 21n here on the left, and that's more n's than the negative 10 n's on the right here. So I'm going to add 21n to zero it out, and to make my coefficient of n positive. So that zeroes out there. I've still got this 12, and it's less than this negative 24, and negative 10n plus 21n would be a positive 11n. Next, we'll isolate the n's by adding 24 to both sides. So 12 plus 24 would be 36, and this is less than, of course that zeroes out right there, and we'll drop that 11n right there. The final step is to make this 1n by dividing both sides by 11. So n, and we're comparing this with 36/11ths, that cannot be simplified. So 36/11ths is less than n, but again, you may have written it like this, with the n on the left side of the inequality, but again, it just needs to be eating the n in comparison to that 36/11ths. So either one of these would work. They mean the same thing, so either one would be the correct answer. All right, let's go ahead and do number 7 with your partner. We will give you guys a couple minutes to do this one. So work with your partner, talk about it, see if you can figure it out what the answer is for this inequality. A couple minutes, go. All right, hopefully that was enough time for you guys. Let's go ahead and do this one. Number 7. We have a couple numbers that we need to distribute into the parentheses, the negative 10 and the negative 2. So that'd be negative 10 times n, which is negative 10n, and also negative 10 times 8, positive, which would be a negative 80. The negative 2 also distributed, so we have negative 2 times 12, which would be negative 24, and also negative 2 times 5n, which is negative 10n's. So our new inequality, negative 10n minus 80 plus 12, and this is greater than or equal to negative 24 minus 10n. So let's go ahead and isolate the x's. Actually, I see I can combine these two like terms here. Negative 80 plus 12, that would be negative 68 right there. So our new inequality is negative 10n minus 68 is greater than or equal to negative 24 minus this 10n over here. Fix that minus. All right, so let's isolate the n's. So I just want them on one side of the inequality. So I'm going to add this 10n to both sides. But something else happens when I do that. So this zeroes out, and I'm left with negative 68 is greater than or equal to negative 24. But in addition to the negative 10n canceling out or zeroing out on the left, it also zeroes out on the right. So I could show that plus 0, but it's not really going to do me any good. So I've got negative 68 is greater than or equal to negative 24. This right here is a false statement. And since it is false always, that means this one simply has no solutions. So what this also means is that it doesn't matter what value you replace n with, you will never get a true statement from this. All right, here's number 8. It does have fractions. That shouldn't be a problem right now. Take a couple minutes and solve this one for A with your neighbor. Go. All right, let's go ahead and solve this one. So on the left side, we got like terms with the A's. And I need to show that as negative 2 over 1 so that I can combine the fractions on this. Now, you could plug into the calculator to combine these. You'd plug in negative 2 plus 5/3. I'm just going to show the work for that. So negative 2 plus 5/3. But again, that's negative 2 over 1. So I'm going to make the denominators the same. That would be negative 6 over 3 plus 5 over 3, which would be negative 1 over 3. So we end up with negative 1/3 of an A is less than or equal to negative 8/9. So I'm going to do this in 2 steps, even though you could do it in 1. I'm going to get rid of that 3 denominator first by multiplying both sides by 3. So that cancels those out as a 1. So I end up with negative 1A is less than or equal to, just plug this into the calculator again, we want the fraction, so this would be negative 8/3. And I just simplified the 3 and the 9 into a 1 and a 3. Well, I've got negative 1A is less than or equal to negative 8/3, but I don't want negative 1A's, I want 1A's. So I'm going to divide both sides by negative 1. That will give me a positive 1A, which is what I want. But by dividing both sides by the negative here, it's going to flip the inequality. And we end up with a positive 8/3 instead of the negative 8/3. So this would be our answer for this problem. So in the next few examples, we got to remember how to graph the inequalities. We're not just going to be solving them, but we'll be graphing them as well. Just remember, if it doesn't have the equal part or condition for the inequality, it's an open circle, which means it would not be included in the solution set. If it does include the equals, like it does in these two, then it's a closed circle. The next thing for both of them is we've got to figure out which way the line goes on the graph. If the inequality eats the letter, the line goes to the right. If it does not eat the letter, then it goes to the left. So in other words, if we saw something like this, where it was x is less than or equal to 10, then on the number line at 10, this one shows that it would be a closed circle because it includes the equal part of it. It's not eating the x, so it would go to the left, which means that 10 is a solution here, but also anything to the left of 10 on the number line would give a true statement for the original inequality, like x is less than or equal to 10. So let's go ahead and apply that on 10 and 11. Take a moment with your neighbor and see if you can solve these two for the unknown. So solve the two inequalities and then graph them as well. Couple minutes to work with your neighbor. Go. All right, between these two, we're going to start with number 10, and then we will graph it also, and then we'll do number 11. So number 10, to solve this one, first thing I see, there's no need to combine any terms because there's no like terms. And also, we can just start by isolating the v's. There's no distribution either. So let's go ahead and get rid of that negative 8 by adding 8 to both sides of this inequality. So negative 9 plus 8 would be negative 1. This is less than or equal to, of course this zeroed out, so we just have v, positive v over 8. Now what I'm about to do is get rid of that divide by 8 by multiplying both sides by 8. kind of an inverse operation thing. These cancel out into a 1, and I have a v. But remember, I multiplied both sides of the equation by a positive, so it does not change the inequality. 8 times negative 1 is negative 8. So you could have gotten this one, but of course there was a second way to write it. You may have had v is greater than or equal to negative 8. Either one of these inequalities works. So on my graph, I'm going to go to negative 8, and since both of these include the equal condition for the inequalities, I'm going to make that a closed circle. Both of them are eating the v's, so it would go to the right. And that would be the graph. Next up, number 11. This one does include distribution. That's okay. 5 times 9, that would be 45. And also 5 times positive n would be positive 5n. So the new inequality, 5 is less than or equal to 45 plus 5n. Now I'll isolate my n's by getting rid of that 45, so subtract 45 from both sides of the inequality. That zeroes out that 45. 5 minus 45 is negative 40, which now is less than or equal to 5 of these n's, which we dropped. The last step here is to divide both sides by 5 to make that 1n, because 5 divided by 5 is 1. So n, and again we divided both sides by a positive, so it doesn't flip the inequality. But negative 40 divided by 5 would be negative 8. Once again, you may have written this as n is greater than or equal to negative 8 as well. And that would also be the same solution, just written differently. Just notice that the inequality is eating the n. That's what we need to see. So to graph this thing at negative 8 for both of them, it's a closed circle because they both include the equal part of the inequality. Both are eating the n, so this line goes to the right. Now again, this means that any values to the right of negative 8 on the number line would give us a true statement. So on the original inequality, if I put a negative 4 in for n up here, it would still give me a true statement. All right, here's 12 and 13. Take a couple minutes with your neighbor, graph those after you solve the two inequalities. Give you guys a few minutes to do that. All right, of these two, I'm going to start with number 12. We'll go and solve that inequality, then we'll graph it, and then we'll do number 13. All right, the first thing I'm going to do, there's no distribution, there's no combining like terms. So the first thing I want to do is get rid of that 1 so I can isolate my x's. So that's going to zero that out. The other one zeroes out as well, but it's okay right now. I'm going to keep that 0. So I've got x over 3 is less than or equal to 0. Now to make that a 1x, I'm going to multiply both sides by 3. So 3 divided by 3 is 1. And I've got x now is less than or equal to 0 times 3, which is 0. So of course you may have solved it differently and you may have gotten 0 is greater than or equal to x. Either way, it works the same. So at 0, I'm going to have a closed circle because it's also got the equal part to it. These ones are not eating the x though, so this line will go to the left. And that would be the graph. All right, on number 13, we do have distribution, so I'm going to be distributing this negative 3 into the parentheses. So that would be negative 3 times x, which would be negative 3 x's. and also negative 3 times negative 2, which would be positive 6. So the new inequality is 12 is greater than negative 3x plus 6. And I'll isolate my x's because there's no terms to combine, no like terms. So subtracting 6 from both sides, I got 12 minus 6, which is 6. These zero out. So I have 6 is greater than negative 3x. Next up, we'll divide both sides by negative 3, which will give me the 1x. However, I did divide both sides by the negatives here, so that's going to flip the inequality. And 6 divided by negative 3 is negative 2. Of course, if you wanted to, you could have written this as x is greater than negative 2. Either one of these inequalities will work. Now we're ready to graph this. At negative 2, this will be an open circle. Again, going back to the original inequality, if you replaced x with negative 2, that would give you a false statement because it would be equal. Next up, I see in my two inequalities that they are eating the x's, which means that from negative 2, this would go to the right. So anything to the right of negative 2 would make the original inequality true. All right, here's numbers 14 and 15. Take a few minutes with your neighbor, see if you can solve these, and then we'll go over them together. Few minutes, go ahead. All right, hopefully that was enough time for you guys. If not, again, finish up and then follow along with us. Let's start on number 14. On number 14, I have some distribution here. So I'm going to distribute this 10 into the parentheses. So that would be 10 times n, which would be positive 10n. And also 10 times positive 5, which would be positive 50. So the new inequality now, I have 230, which is less than or equal to 10n plus 50. Next, I'll isolate my n's by subtracting 50 from both sides. So the n's are on their own side of the inequality. 230 plus 50. I wrote plus 50, that should be minus 50. There we go. 230 minus 50 would be 180. So the new inequality, 180, is less than or equal to 10n, because these 50s zeroed out. The last thing, in order to get the 1n, is to divide both sides by 10. So 10 divided by 10 is 1, and this would, n is greater than or equal to 180 divided by 10, which is 18. So the other inequality would have been n is greater than or equal to 18. Of course, the one we have is 18 is less than or equal to n. So we're ready to graph this then. At 18, this would be a closed circle because it includes 18, because it's equal to on these parts. And then it eats the n, so this line would go to the right. And that's the graph for number 14. Next up, number 15. So let's go ahead and multiply both sides by 8 to get rid of that denominator, which we can do. So 8 times negative 1 is negative 8. Now I didn't multiply by a negative, so it's not going to affect the inequality. However, the 8's do cancel each other out as a 1. So negative 8 rather, is greater than or equal to x minus 5. Next, we'll add 5 to both sides, and that will isolate the x and also solve this one for us. Negative 8 plus 5 is negative 3, which is greater than or equal to the x. So again, you may have gotten x is less than or equal to negative 3. Either way, this works. So at negative 3, I have a closed circle. This one is not eating the x, so the line goes to the left. So there's our inequality and graph. All right, you guys take a few minutes to do numbers 16 and 17 with your neighbor. Talk about it, see if you can solve those together, and we'll go over them together as well. A few minutes, go. All right, that's enough time for that. Let's go ahead and go through 16 and 17 individually. Starting with number 16, we'll solve it, and then we will graph it. All right, number 16, just like the last problem, I think number 15, I want to get rid of that fraction, so I'm going to multiply both sides by 12. So that cancels the 12s out, and I'm left with that n plus 7 business, which is greater than or equal to 1 times 12, which is 12. But I want that n by itself, so I don't want that plus 7 with it, so I'm going to subtract 7 from both sides. Now subtracting doesn't do anything to the inequality. What it does is zero out the 7s. So n is still greater than or equal to, but 12 minus 7 is 5. Of course, you may have this written as 5 is less than or equal to n, and that would work too. In any case, the graph will look the same. So at 5, I'm going to have a closed circle because it's got this equal part of the inequality, and it's eating the n, so it goes to the right. Next up, number 17. So on this one, no distribution, no fractions on this one. Let's go ahead and just get rid of that negative 2 by adding 2 to both sides of this inequality. So that zeroes those out. Negative 32 plus 2 would be negative 30, which now is less than or equal to that 10n. The final step here is to divide both sides by 10. So that leaves us with the n, because 10 divided by 10 is 1. Negative 30 divided by 10 is negative 3. Once again, we did not divide both sides by negative. So this remains negative 3 is less than or equal to n. Of course, if you were to switch it, you'd have n is greater than or equal to negative 3, which mean the exact same thing. So at negative 3 on this number line, wasn't marked with the negative 3, but we know that it's between, halfway between negative 2 and negative 4. So it's a closed circle because these ones are equal to, and it's eating the n, so this line here goes to the right. And that would be the graph. All right, here's numbers 18 and 19. Take a few minutes with your neighbors, solve these together, then we'll go over them. All right, hopefully that was enough time for you. Let's go over 18 first. We will solve it, and then we will graph it. All right, number 18, it's got that negative sign in the front of the parentheses, which means it's really negative 1. So I'm going to be distributing this negative 1 into the parentheses. So negative 1 times n would be negative 1n. Then also negative 1 times negative 1, which is positive 1. And this is less than the negative 1 there on the right. The next step is I'm going to isolate my n's by subtracting 1 from both sides. So that leaves me with the negative 1n. These zero out, and I've got this is less than negative 2. The next step is to divide both sides by negative 1 to make that positive 1n. But I did divide both sides by negative on this one. So I'm going to flip the inequality. And negative 2 divided by negative 1 is positive 2. So you may have gotten this, or you may have gotten 2, which is less than n. Either one of these work. Next up is the graph. So at 2, this is going to be an open circle because it's not equal to the n. It is eating the n, however, so we're going to draw the line going to the right. which again means anything on the right of 2 would give us a true statement in the original inequality. All right, number 19. So I'm going to isolate that negative 3a by adding 6 to both sides of this inequality, so that zeroes them out. 39 plus 6 would be 45. So the new inequality, 45 is greater than the 3a that remained. I'm sorry, I wrote that as positive. It should be negative right there. So now to solve for a, I'm going to divide both sides by negative 3. And since I did divide both sides by negative, that's going to flip the inequality the other way around. 45 divided by negative 3 would be negative 15. And negative 3 divided by negative 3 is 1. That's what we wanted, 1a. So yes, you could have written this as a is greater than negative 15 as well. So the graph at negative 15, which is halfway between negative 14 and negative 16 there, that's going to be an open circle because it does not include the equal part or condition for those inequalities. They are eating the a's, so this line will go to the right, and that would be the graph. All right, that concludes the worksheet. So I can solve and graph multi-step inequalities, which you should feel pretty comfortable now doing. Whether it's solving or graphing them, again, it's just like solving equalities, except if we ever multiply or divide both sides by a negative, then we're going to flip the inequality. All right, thanks for watching, you guys. If this lesson helped you out with solving and graphing multi-step inequalities, please subscribe to the channel, like the video, and make a comment below. See you guys in the next one.